Okay, we get a little practice working with a new formula here. It's the force of either attraction or repulsion between electric charges. Here's what we know. We know there's two charges. We know they're identical, but that's all we know. They're 5 meters apart, and there is a 0.3 Newton force repelling them away from each other. All right, here's what we need to find. We need to find the magnitude of those charges, and then what can we conclude about the sign of those charges? All right, so here's how it works. We were given the force, and we were given the distance between those two charges. So I thought before I substitute in all the numbers, I wanted to show you how to rearrange it with just letters. Hopefully by now, we're in course 3, you're probably becoming a whole lot more comfortable solving algebra problems with just the letters. So here's what it looks like. I know the force is equal to Q over R squared. That K is called Coulomb's constant. It's pretty close to 9 times 10 to the 9th. All right, so first thing I did was solve for Q, and then I realized, ooh, I did like 3 steps there. I better show you like what happened. So the first thing I did is I know these two Q's are the same thing. So if I take Q times Q, I get Q squared. I move the K over here, I move the R squared over there, and this was my intermediate step. I ended up with Q squared is equal to F R squared over Coulomb's constant. All right, that's where this step came from. I took the square root of everything, found Q, square root of R squared was R, and I need to take the square root of F over K. Now I put in the numbers. I said Q is equal to 5 times the square root of 0.3 over Coulomb's constant. Threw that into my calculator and I got some number close to 2.89 times 10 to the negative 5 coulombs. And as you know by now, we usually don't write things with a 10 to the negative 5. That's close to a 10 to the negative 6, and 10 to the negative 6 is micro. So if this has to turn into 10 to the negative 6, this power of 10 got smaller, so this numerical coefficient gets bigger by 1 power of 10. So most of the times you'll see your answer written like this: 28.9 microcoulombs. The second part of the question is, what can we conclude about the sign of those charges? Well, all we know is that they repel each other. So if one of them's negative, the other one has to be negative in order for them to repel. So I know they'd have to be the same sign. The other possibility is if one of them's positive, then the other one has to be positive. So the only thing I can conclude about their signs is that they'd have to be the same in order for them to repel. All right, I'll see you in the next problem.